The next topic in the arithmetic power hour is a discussion of large versus small numbers. So here's a summary or a preview of where we're going. We tend to think that numbers get bigger when you multiply and smaller when you divide, but that is only true when you're multiplying or dividing by large numbers. Small numbers give the exact opposite results. So there's a lot packed into that statement. Let's blow up the board and see what I mean. So when we were in elementary school, we learned multiplication and division with whole numbers. And we noticed some patterns. We noticed perhaps that multiplying makes numbers larger. For example, 3 times 5 equals 15. Now that 15, the product, is bigger than both the 3 and the 5. So to sort of generalize this in our minds, I'm sure that we didn't all think in algebra language, but this is basically what we thought. If you take two numbers, m and n, and multiply them together to get a product, p, then that product must be bigger than m and also bigger than n, as borne out by this example. Okay, so the point that I'm making today is that that is true as long as m and n are big numbers. What exactly do I mean by a big number? I'll come back to that in a minute. And then we also thought in elementary school that division makes numbers smaller. Here's an example. 100 divided by 4 is 25. Now this answer 25 is less than the 100 that we started with. So maybe that's always the case. In other words, if you take any two numbers, m divided by n, to get their quotient, q, maybe that quotient will always be less than m, the number you started with. And again, that is going to be true as long as n is a big number. Okay, so I need to carefully define what I mean by large and small numbers. The upshot here is that these common sense concepts are true as long as n, the number that we're multiplying or dividing by, is large. So it's very simple. On the number line, basically the number 1 is the cutoff point. The numbers that are larger than 1, for example, numbers like 2, 3, and 4, for the purposes of this discussion, are what I mean by large numbers. The numbers under 1, such as a half or a 0.9, are small. So sometimes I say that 0 and 1 are the most important numbers on the number line. Now let's tie this into something we've discussed before, which is plugging numbers in. Sometimes when you're doing a quantitative comparison problem, you can solve it by plugging numbers in. And I've advised you to make sure that you plug in numerous diverse numbers. For example, you probably want to make sure that you're plugging in not only large numbers like 2, 3, and 4, but also small numbers like a half or 0.9. It's also a pretty good idea to actually plug in the numbers 0 and 1 because they're special numbers. If we went to the negative side of the number line, -1 would be equally important. But for this immediate discussion, I'm leaving negatives out of it. I'm just talking about the distinction between small and large numbers. So the rule that I'm getting at here is that if that number n is small, if the number that you're multiplying or dividing by is small, then the results we just discussed will be backwards. So small numbers have opposite behavior of large numbers when we're multiplying and dividing. This is really just the analogy, by the way, of positive and negative numbers. Negative numbers behave opposite of positive numbers when you're adding and subtracting. When you add a negative number, you get smaller. All right, but going back to multiplying and dividing, so for example, 3 times 5 is greater than 3, and that's true because 5 is a large number. But now if we multiply 3 by a small number, 3 times a small number is going to give you a result less than 3. Likewise for division. Here we're dividing 100 by a large number. Therefore, the answer must be less than 100. But if we divide 100 by a small number, we get the exact opposite result. We're going to get something larger than 100. It's 400 if you work it out with the reciprocal. Here's a mini quiz to make sure you understand this principle. The given is that x is a positive number. X is greater than 0. And we're going to do a couple of quantitative comparison exercises. Question number 1, which one is larger, 5 or 5x? Mark the answer that you believe is correct. If you need time to think about it, pause the video. Question number 2, which one is larger, x or 5x? Mark the answer that you think is correct. Again, if you need more time, pause the video. And here are my answers. The answer to question number 1 should be D. There's not enough information to tell because we don't know if x is large or small. We know that x is positive. So we know that x is to the right of 0, but we don't know if it's to the left or right of 1. If x is large, then B would win. If x is small, then A would win. We don't know. Answer is D. The correct answer to number 2 is B. 5x is always going to be bigger than x. Why is that? Because here the multiplier is 5. It doesn't matter what x is. X could be a small number or a large number. But if we multiply it by 5, 5 is large, so the result will be larger than x.